Hi, this is Dockerized Live, and today we're going to talk about removing complexity from the integration tests using test containers. Many years ago, when computers were big, phones still had buttons, and programs were larger, we figured out that we need tests to have our application solid and reliable. We want to release with confidence, and for that, we need automated tests to check the quality of our stuff. And then we had different types of tests. And then we figured out that we will have as many as possible of those small tests that test isolated components of the business logic. And then on top of that, build the foundation of the integration tests, which are longer to run, harder to maintain. And then they would test the system with different components in use. And then on top of that, the end-to-end tests, which probably will use the similar to production deployment means the full deployment environment, and then they will be hardest to maintain, but they will test maybe the most useful user focusing workflows. So that was a long time ago. And then something changed. What changed is we started doing microservices. And apparently this situation where we'll have a ton of unit tests didn't cut it anymore. So we started thinking about how people can do testing better. A few years ago, engineering folks at Spotify described how they test their microservices was something called the microservices technique, honeycomb. They changed the shape of their test suites to include much more integration tests, figuring that the components of the microservices are so small that there are not enough implementation details to test because, well, you don't deal with a lot of business logic anymore, but the business logic is encoded in how different components integrate together. You have microservices, they depend on databases, message brokers. All those components need to be tested, and integration between those needs to be verified. And then at the top still, there are like full-blown end-to-end integrated tests in the close to real production environments. But the bulk of the tests that we run for our automated, not we, but they ran for the automated test suites are the integration tests, which is very interesting. We're going to talk about how you can do integration tests better. My name is Oleg Šelajev. I work as a developer advocate for AtomicJar, and I'm very happy to see all of you here. Integration tests are an incredible tool. Imagine we have a system of microservices with those squares you see on the screen. For testing any particular component that we have control over, imagine we're developing the red square application, we need, for its operational life, we need its service dependencies, the other squares. And those service dependencies can form a very complex graph of interdependent services as well. Those could be an out-of-the-box stock software like MySQL or Postgres or Kafka or Elasticsearch, or there could be other services that either we ourselves develop and maintain, or other people in our team or in our companies develop and maintain. So testing this whole deployment is very complicated. It's hard to maintain because there are very many different parts that are also moving together with our application, which means that testing and speeding up the whole environment is probably very expensive or impossible. Imagine if you are a big company with a ton of microservices, nobody knows how to start Netflix or Uber from scratch. You only know how to add things to the ever-evolving live deployment there. Especially you cannot do it on a local development machine or in smaller CI instances. That means that you definitely will have a mismatch between what developer sees and how they can interact with the application and the tests, and with what the CI sees or the later stages of testing see. So we don't want to do that. For the integration tests, for successful integration tests, what we want to do, we want to limit the exposure to the rest of the deployment to one level. We only want to have and spin up the environment where one level of dependencies is included. That means that for our application, we want to replace the green bubble there with a double. And that double would be a stock application and stock software in case of the database, or if it's a message worker, if it's something that we can run anyhow. Or it would be a test double, say the mocked service on the service level, if this is some third-party API that we cannot easily spin up ourselves. The good thing is, in both cases, we know that this double is trustworthy because it's either the same software that we run in production, the same database version, or the same service version, or this is the mock double that we can verify the correctness of which using the contract testing. We don't have to do that. The other teams that are maintaining those API and microservices can verify the correctness using the mock testing. But the benefit for us is that we only have the service dependencies that we control. And if any of the tests will fail, that means that issues are in our code, in our red bubble on the screen here. And that means that we can fix them and move forward. And if there are any issues in other components, they will be discovered during different test runs. And then people who maintain those will be able to fix those. So this is a brilliant approach where we want to limit the service dependencies for one level around our application, and that would be our integration test environment. And then we're going to spin them up locally on our development machine or in CI, and going to run the integration tests against that environment. And we want that to be as truthful to the production as possible. And we want that to be as easily maintainable as possible, because we want to do that all the time in development, in CI, on your colleagues' workstations, anywhere. That's where Docker comes in. Docker is an incredible software that popularized how we run applications on our machines. And it's brilliant for two very large use cases. One is, of course, how we can give other people our applications to run. We can package it in a Docker image and give that image to somebody else, and they can run it the same way we would run it, which implements very important consistency that we'll need to have for integration tests. The dual of this is, of course, that we can the same way run other people's software, and this is exactly what we're going to use for the integration tests. We're going to use Docker to isolate all the service dependencies that we have in our integration tests, and we're going to run the apps on our machine, but with the isolation of the Docker. And it's perfect for that. First, it is multi-platform, so it supports all operating systems. That means that your whole team can run the same things in the same way. It also supports processes isolation, so we can run whatever complex software we need, like an Oracle database or Kafka. And it gives us access to the file system, network, and configuration for the limits, and anything that we want to configure within the container. Unfortunately, integration testing is a very extensive use case for spinning up services. We want to configure multiple services at the same time. It could be multiple different services connected with networks, or it could be the multiple instances of the same service. We want to be very flexible in our integration test because we need to create the scenarios on the fly, both with data and the configuration for the services. And we want that configuration to be dynamic because we want to parallelize execution. We want it still to be reliable and isolated because we want to have the consistency between the different environments, but we also have an unprecedented level of flexibility. And this is where Testcontainers comes in. Testcontainers is a collection of libraries that integrate with the Docker API to be able to instantiate containers and manage their lifecycle. On the other hand, Testcontainers integrates with the testing and application frameworks to provide you an API to control those Docker containers and naturally use them from your integration tests. It's a fairly old project. It's a mature project. It started more than 7 years ago. I think we had a birthday a few weeks back. It's an open source thing. It started with the Java implementation, which uses the Docker Java API. And besides just allowing you to manage containers, it takes extra care for providing you necessary utilities to make your integration tests as reliable as possible using the automated Docker discovery checks and the checks that we can use the Docker environment properly. Very important is the automatic cleanup. So the resources that you allocate, the images, the containers that you run will be automatically turned down after the tests pass or even fail unexpectedly. So it tries to create the very reliable environment for you to spin up containers. And it has the programmatic API, in this case in Java, that you can use to control those containers, how they interact, how your application interacts with them. And it all comes together very, very nicely. So your integration tests start feeling like unit tests, and also they're straightforward to manage and control. Besides being a library in Java, it's also the library that has been ported to other languages. We have Testcontainers Go, Testcontainers Node, Testcontainers Python, Testcontainers Rust, Testcontainers.net. So all the teams that use those popular programming languages can use the Testcontainers approach and write integration tests using similar concepts with the similar ease and consistency. Don't take my word for this. ThoughtWorks recently published their technology radar, where they put test containers firmly into the adopt category and said very nice things about test containers, saying that they think it's a useful default option for creating reliable environments for running tests, and that the programmable disposable containers for the integration tests make those tests more reliable. Besides ThoughtWorks, a lot of people and a lot of teams are using test containers. So we recently crossed the 6 million downloads per month for the main artifacts, and it's not just CI builds cranking out the builds, because we also see the growth in the unique IP addresses. So more and more people and teams are using test containers all over the world, and I'm going to show you why and how. We're going to look at a sample Spring application. My background is in Java, so that's the Java application. And it's going to be a very simple one. It's going to talk about conferences and talks and ratings for those talks. And it's going to use a complex set of service dependencies that it needs for its lifecycle. There is a database, there is a Kafka that is used for the components to talk with each other, and there's also Redis. It might be a little bit an overkill for such a simple application, but it also will show how easy we can create the environment for our application to run using test containers. Let's go to the IDE and find out. I have my IntelliJ IDEA here. This is a demo application. You can see that it's exactly the thing that I just talked about. We have the ratings controller that uses the Kafka template, and then it uses the repository for storing ratings using Redis, and then it also uses the talks repository for storing talks that talks to the database. This is excellent. I cannot even run this application because I don't have the database and Kafka on my machine running anywhere, but we have some tests here. So if we go into the demo application tests, we can see a fairly extensive test suite for this application. So we verify that Spring application loads, and we have some talks in the database. So we want to have access to database. We can verify that a health endpoint returns 200. So our application starts normally and reports that its environment is sufficient. And it's also, we use this application properly. We are submitting ratings to the /ratings URL, and then we're waiting for them to propagate through the application, and we want to see them back. So as you can see, currently the tests are failing because there are no environment for my application. Let's create some. We're going to put this in the abstract, in the superclass for simplicity. And we need the 3 components: Redis, database, and Kafka. Let's start with it. At the same time, we're going to look at what test containers abstract concepts you need to know to run the tests. So the main of this is the generic container. So we're going to create a static field with the generic container, and we're going to say this is Redis. And it's going to be the new generic container. And all we need to do is to provide the image name. So we're going to say we want Redis with a certain tag, say Alpine. Now, this is all that you need to have for the definition to have a fully functional container, containerized Redis running from your application test. Now, on this one, I have the whole API that I can use to configure my containers from the comfort of my IDE. I can expose certain ports from within the container, or I can copy files somewhere into the container. I actually do need to expose a port because Redis, we're gonna use Redis through the internet. So we're gonna expose the port 6379 here. It will be mapped to a random port on our host machine because we don't know whether we want to run two Redises, so we cannot use the same ports because there will be a conflict. Testcontainers takes care of that. And now after this, we can just, for example, use the lifecycle methods or integration with JUnit or integration with application frameworks to start the Redis container. To have this generic container API, I need to include the dependencies on test containers, and you can find them on Maven Central, or for other languages, that would be the normal way how you consume the dependencies there. So for Node, that would be npm, or you do go get test containers and similar. So I have the dependency on the Kafka module, on Postgres module, and integration with JUnit Jupyter. So we have our Redis. What we need to do, we need to start our Redis. So we can use the startable Redis. We're going to start it, and we're going to join on the future. And now we need one thing to configure. Because our Redis will start on the generic random port, we need to configure our application to actually connect to that particular Redis instance. And that is done using this simple configuration. This is a Spring application. So for the Spring application, there is a certain convenience methods. For example, if something is annotated with dynamic property source, it will be executed before the test. So we can use this to add to the registry of configuration the host and the port of our Redis. And we get them from the container itself. So the container is smart enough to know that we're going to access certain configuration from it. And it just provides us with the host and with the mapped port on the host for the port for the Redis. Let's do Kafka now. How many of you know how to run Kafka in the Docker container? With test containers, it's very simple. So we do Kafka container, and we call it Kafka. And we just say new Kafka container. We need to specify the image name here as well. And we can do using the Docker image name DSL for that as well. So for example, if I want to run the Confluent image, so this is Confluent Inc. CP Kafka. There is a DSL for this as well. Test containers is very important. One of the important goals for test containers is to provide you as a developer with tools to use and configure your Docker environments and Docker images without actually knowing what Docker needs to do. So everything is encoded in the API, which your IDE assists you with, because, well, you just click dot and then you see what you can do with those. So we can do with tag, and we just need to provide a version. I know that 5.4.3 should work nicely. So now we have Kafka. We need to start the Kafka because otherwise it would not work. And then we need to add the configuration for that. I know that the property is called Spring Kafka Bootstrap Servers. This is for Spring to connect to our Kafka. And instead of talking to Redis, we're going to say Kafka. And we just helpfully, our IDE gets us the method that we need to call. It's the accessor for the Bootstrap servers. Somebody who knows how to run Kafka in a container implemented this Kafka container abstraction for us, implemented all the configuration that we need to run Kafka properly, and also provided us with API to have the convenient methods to configure our applications. That is the beauty of test containers. Somebody who knows how to run things in Docker provides abstractions for you to use from the comfort of your IDE. The third piece that we are missing is the database, and we're going to use something called the JDBC URL implementation instrumentation magic to spin up that container. So I could create the Postgres container just like this, the same way, and configure it manually. But also, I want to show you the simplest way to add test containers based containers into your integration tests. So if you have an application, you can just configure it to use a certain property for where the database locates, right? So for Spring, that is Spring data source URL. And normally this would be a JDBC URL pointing to your database. And in our case, we're going to do JDBC, and we're going to instrument that with the TC suffix here. So when the Spring application goes and looks for the driver, it will find the test containers JDBC driver, and that driver will spin up the Docker image that we're going to specify here by its name, and it's going to run that database, and it's going to configure Spring automatically to run and use that database. This is the driver configuration. So we need the Postgres for this app. So PostgreSQL, and we need tag. I think 14 Alpine is a pretty small image. And we just say whatever database we want, test containers, DockerCon. The database name and the schema names, they all will be populated back into the application configuration. You can do that manually if you create the containers manually using something like this, or you can get, say, new Postgres container and say we can have it here, Postgres container, and then you can just say get JDBC URL or database name or username, so you can configure your application nicely and properly. So now we have Redis, we have Kafka, we have Postgres. So I think if we run the test, they should pass now. Let's see. So we start the tests. Let's see what happens here. We discover the Docker environment that we're connecting this thing to. And we run our Docker containers. We run Redis, we run Kafka, we run Postgres. Somewhere should be Postgres as well. We run Postgres, and then we are running the tests, and our tests pass in no time. Let me show you that again. We just run, and in a few seconds of time, we have a complex environment created that is repeatable and complex environment that just creates the all necessary components for our application to run, and it runs, and you can see that it actually is healthy. The context loads, the database is there, Redis is there, and Kafka is there as well. So that was a quick demo. I hope you like that. It's very straightforward to use test containers, and it's also, there are more available to that. There's a whole configuration that you can use. You can extend the life cycle of your containers beyond one test run, so the containers are not cleaned up automatically. That helps with debug sometimes. You can create more complex topologies where containers need to talk to each other. You can create custom startup and waiting strategies, which is very useful when you create the modules yourself, and you can specify when the container is considered started. So it's not just when some ports are available, but for example, when the database is actually ready to accept connections and do something with the data. You can create the images for the Docker on the fly. You can access logs files, run special commands, run commands with the containers running, specify limits, and all in all, the configuration and possibilities are endless, and it's just a very useful tool for you to create reliable but tied to your code in execution environments for your integration tests. And of course, you can do similar with other languages. For example, for Go, you will have something like this, where you would use Go for the same concepts. You will create a generic container and you will run it, and then you have an ability to terminate that and use the lifecycle. You have the node-specific async first API for your node tests. So use the same way you can create the container or a module for the dependencies that you want. And this, it can run Docker, anything that runs in Docker, databases, message brokers, Elasticsearch, Kubernetes clusters, IoT platforms, and everything else. At AtomicJar, we're working on creating something called Testcontainers Cloud, which is a product where we defer execution of the test containers based Docker containers to the cloud in the serverless platform. If you want to run your tests and move some of the computation power to the cloud, you might want to check this out. It's currently in private beta. And if you don't want that, then you should just look into Testcontainers. The code for this sample application and obviously the libraries is available. There are resources that you can use, and I'd be happy if you look into that. And also, if you're watching this, can you please star the particular dependency for your favorite programming language at the repository on GitHub? I just want to check how many people from different communities are watching us, and I will be watching the numbers skyrocket after the DockerCon. Thank you very much.